Yes, sir.
So as we know, in last class we studied impulsive force and as well as impulse, and we have been made a formula for impulse. So if you want to say simply, impulse means, so what is that? Large amount of force is applied in a short period of time. So that is what we used to call as force into time, which is basically we used to call as impulse. Or we can say that impulse means change in momentum. Am I right, guys? Everybody? Change in momentum is only we used to called as impulse, which we studied in yesterday's class. Is it right or wrong? All of you. Change in momentum means what? Yes, please.
Impulse.
Final momentum minus initial momentum. So that is what we got the formula for impulse. So those are absent in yesterday's class. You have to go through that and you have to watch everything and you have to take the notes. So now in today's class, we are going to see the next concept, which is also very important. So that is what
Sir, and also change in momentum by time.
yes, yes. So we can make that also, Mari. Nothing wrong there. So today's class, we are going to see the next concept is mass and weight. So please, all of you keep reading mass and weight. Okay. So till now, you can see in our daily life, up to the 8th class or even till today, we all people will use. Suppose I will ask you, what is your weight? Anybody? For example, I'll ask Agalya. Agalya, what is your weight? Yes. Mari, what is your weight?
50 newtons, sir.
50 newtons, 50 kilogram. Don't speak
50
like a
kilograms,
person.
sir. Sorry, sir.
50 kg, we will say. So that
Yes,
is,
sir.
but actually, we are using a word called as weight in our daily life, and we are saying a word called as 50 kg, 100 kg, 20 kg, and etc. So what we are saying is actually not a weight. We are asking a word called as weight is a common word, but actually we are actually describing about the mass. So mass is different and weight is different. So what we are studying, mass is entirely different from weight. So let us discuss what is mass and what is weight first. So all of you remember mass first. What do you mean by mass? Means mass is the amount of matter present in our body. So for example, if you go back to the class 6th and all, matter. What is the definition for matter, everybody? Definition for matter.
Occupies
Yeah,
space and
Object
have
that
matter.
occupies space
it
and
Occupies space and
occupies space and having mass. That is what
Mass.
is called as matter. Am I right or wrong, all of you? Now, mass means mass is the amount of matter contained in a body. Like everything, if I take your body, flesh, blood, hair, each and every part of our body is a matter. How much matter is present in our body is only your mass. Do you all understand what I'm saying? How much mass? What do you mean by mass? Means the matter present in our body, whatever it is. It may be a water content or maybe blood or maybe some other XYZ. Each matter, the total matter present in our body is only called as what, guys? All of you, mass. Understanding, all of you? So mass is the amount of matter contained in a body. So that is what we used to call as mass. Now, if you see that this mass is directly proportional to first law. Anybody can tell what is the word we use there? We studied already. Anyone, please?
mass and inertia.
Yes, that is why we studied by the time inertia is the measure of mass. Am I right, Mr. Sanjay? Lingesh?
Sir, mass is the measure of inertia.
Yes, ma. Inertia is depends on mass. Am I right, Mari?
Yes, sir.
That is why we will say inertia, mass of a body is the measure of inertia. So that is the reason we will say inertia is depends on what? Everybody, girls, inertia is depends
Mass
on
of the body.
mass.
That is what.
Mass.
If higher the mass increases, inertia is also increases.
Increases.
Mass decreases, inertia is also decreases. Both are directly proportional to each other. That is what we studied. Am I right, guys? All of you? So that is what mass. So now this mass is actually, suppose I will ask you, what is your mass? Mari said 50 kg. Actually, we will use a word called as general language. We will use a word called as what? Everybody, weight. But actually it is a what? Mass. Now, you tell me, I'll ask Mr. Mari, what is your mass? I said, what is your mass, Mari? You said 50 kg. Are you
50
saying
kg.
50 kg towards the east, 55 kg towards the west, 70 kg towards the north? Or any direction your mass is 50 kg? What is your mass? Any direction. There is no specified direction. So that is why we say mass is a scalar quantity or vector quantity. Everybody.
Scalar.
Mass is
Scalar
a
quantity.
scalar quantity. There is no specified direction, so that it is called as scalar quantity. Is it clear, everybody? Mr. Kishore, Lingesh, Hasinis,
Yes, sir.
both Hasinis. That is what. Now, let us take all of you observe. What is the SI unit of this mass? I want to know. Anybody can tell? All of you? SI unit, Standard International Unit. What is that?
Sir,
Kilogram.
kg.
Yes. Kilogram is the SI unit of mass. And what is the CGS system? CGS full form, everybody. Centimeter.
Kg, centimeter, gram, second.
So what is the what is the unit? Anybody?
Gram.
Grams. Okay. So that is what you have to remember. So now you tell me, suppose as I said, if this is the earth, now there is a Tamil Nadu here and there is Andhra here, or you go anywhere. Now you tell me, is your mass is remains constant or your mass is varies? Mr. Mari, suppose you are here, your body is having more blood. You will go to somewhere, your body is having less blood. If you are here, your brain is 2 kg. If you go to America, your brain will become 10 kg. Is that possible? Any possibilities? Anybody?
No, sir.
Yes, please.
No, sir.
So anywhere you go in the world, you go to the Mars, you go to the moon, if you go to the sun, if you go to the any other XY place in the galaxies, anywhere, our mass of the bodies remains constant everywhere. It is not changes from place to place. So that is what we will say. A mass of a body does not vary with the position. So please write it. Mass of a body does not vary with position. With the position and remains same. Remains the same everywhere throughout the universe. Throughout the universe, it is remains same. Clear, everybody? All of you? Yes. And how you can measure the mass? Anybody can tell? What is the device you are using? Tamil also you can say. What is the device we are using to measure the mass? Anyone? Yes. How you are checking your mass? Yes, by weighing machine. That weighing machine only we used to called as beam balance. Okay. Olden days, still if you go to the market, we will notice the beam balance. Beam balance means tarasu. Taras terima. Tamil also taras only.
Yes, sir.
Please. So that is what is called as beam balance. Okay. So beam balance means this one. So mass of the body is always measured by what? Beam balance. Okay. But nowadays we have so many electrical balance and lot of things are there. But electrical missions came, so many things. But beam balance is the device which will use it to measure it. What is the Tamil name? Taras only. Am I right?
Tarasu.
Yes,
Yeah,
sir.
Tarasu. Telugu also Trasu. Telugu will say Trasu. In English, sorry, Tamil will
Here
say.
also translate, sir.
Yeah, okay. So whatever it is. So please make it clear, everybody. Understand? All of you?
Sir.
Yeah.
Yes,
So
sir.
this is what about the
Yes,
mass.
sir.
Now, so mass means always remains constant throughout the universe. Wherever you will go, it will be same. So now Sir, is there a prediction when human travel to Mars, they would become Skinner so that mass would be same? Skinner or thinner, amma? Okay, Skinner means okay, that's fine. So by the time, like, see, because of the food lifestyle, their Mars means they cannot be like a normal lifestyle, so that their body decreases. So by the time the mass is varies, I'm not saying that you become a fatty, your mass become increases. You are become a thinner or with a Skinner, you will become a like we can say that mass is decreases. I'm not saying that. For example, now if you take now you are in our earth, you are 50 kg, immediately you go to the Mars, during at this time you will be normal, you will be definitely having a same mass, understanding. But if you stay after 6 months, you stay in the Mars and then you check your mass, by the time mass is not constant. Do you clear everybody? Understand what I'm saying? Yes, that is what. For example, you go to normal, like suppose America, there is no our Indian spicy foods and all, so you become very very lean. So by that time you cannot be, you cannot have the same mass. Understand everybody? Clear?
Yes, sir.
Yeah.
Sir.
So that is what you should remember. So once the immediately if you go anywhere, the mass of the body always remains constant. So what is the SI unit? Kilogram. What is the CGS unit? Gram. And it is measured by a device called as. What is the device we'll use to measure? Everybody?
Beam balance.
Beam
balance.
Beam balance.
is what you have to remember. Next, weight. Now the weight is different from mass. As I told you, weight means 8th class physics also, when you are solving that, I have taught you, weight means I can say it is a force. Am I right, everybody? Yes, please. You might be solving the pressure sums. Pressure is equals to force by area. They will give you that the weight of a person is 20 newtons, like that. Do you remember all of you? By the time I will say the person weighs 20 newtons means, weighs will say that is only the force actually will say. So weight means actually it is the force. That is why yesterday class we studied some other units of force. Do you remember that? Relationship between Newton and Dyne. So I have taught you some other units also. Can you tell me gravitational unit of force? Anybody can tell?
Yes, sir.
Gravitational unit of force. Yes, please. Gravitational unit of
Kilogram
force.
by weight, sir.
Yes. You studied what?
Kilogram.
Hey, I am
Weight.
asked unit, Ramari.
9.8
Gravitational unit
Newton.
of force. SI unit. SI unit.
9.8 Newton.
No, you are not understand the question.
KGF.
kgf or kilogram weight. Do you remember everyone? Gravitational unit of force, SI system, define kilogram weight. 1 kilogram weight is equals to how many newtons? All of you.
9.8 Newton.
9.8 Newton.
First listen the question. Same way CGS unit I have taught you. What is the CGS unit? Gram weight. Or we can
Gram.
say
Gram weight or gram force.
gram force. These are force units when we are working under the gravity. That is what weight. Understanding? So weight, when we are working under the gravity, then the weight is equals to force. That is what force means. Weight, keep it in mind. Weight means force only. So weight means, all of you remember, we are working under
The
the
weight means a force applied on an object, sir.
yes, the force of a object, Mari, not force applied by object. The force of a object is called as weight. Do you understand? For
Yes, sir.
example, this is the ground. Now you are standing on the ground. Means in the sense of you are exerting some force on this ground. Am I right or wrong?
Yes, sir.
The force applied by you on this ground is equals to your weight. Do you understand? Clear, everybody? All of you?
Yes, sir.
But
Yes, sir.
this force is depends on what? It is depends on what? Gravity. Gravity at that place. That is why it is called as. It is having a particular direction always. It is always depends on acceleration due to gravity. So that is what we will say. It is the force acting on a body due to the what, guys? Due to the gravity. That is why it is called as. Understanding? Vector quantity. So we all knows that first chapter we studied, always gravity acts in what direction? Everybody. Gravity acts in downward direction. Understanding? And do you think only Earth will source the gravity? I mentioned you and I taught you. Is it
No,
only
sir.
Earth will source the
No,
gravity?
sir.
No.
No.
Any body in the world, any object in the world having a force of attraction. That force of attraction only we used to call as what? Gravity. Understand? So basically for Earth, we will use a word called as gravity. But generally, we should not use a word called as gravity. What is the word you should use, everybody? Gravitational force. Okay. For any planet or any kind of object, we have to use a word called as gravitational force.
Gravitational force.
But Earth alone, we can call it as what? As we are living in the Earth, we can call the Earth also gravitational force. Or else we can call it as a gravity. So chapter 1 we studied or not? Everybody clear?
Yes,
Yes
sir.
or no? That is what. So there is a force of attraction. Any objects in this world, in this universe, any two objects you can take, there is a force of attraction. That is only called as gravitational force. Do you understand, all of you? Everybody clear?
Yes, sir.
Not only Earth and you, Earth and apple, Earth and pen, or Earth and object. Any object, you and Mars also there is a force of attraction. You and Sun is also there is a force of attraction. That is only called as what force, everybody? That is called as gravitation.
Centripetal.
Gravitational force.
Understanding, everybody? So weight. Weight means it is a force acting. It is the force acting on a body, force acting on a body due to gravity. Understanding, all of you? So that is what we used to call as weight. So weight is equals to, like Newton's second law. What is F is equals to formula? Newton's second law. Mass into
Mass into acceleration.
acceleration. Same way, weight is equals to mass into acceleration. Acceleration, like working against to gravity, A become what, guys?
That 10, sir.
A become G. Understanding? That is for Earth,
Yes,
Mari.
sir.
That is why I'm saying don't get confused. That is only for Earth. Understanding? But this is not only for Earth.
No, sir. I'm saying, sir, we will multiply it with 9.8 or
Acceleration due to gravity. But if you go to moon, it is different, correct, Mari? It is not same. Do you understand?
Yes, sir.
Yeah, be very careful. Okay, va? Clear? That is what. So what is the weight? Weight is equals to, symbol of mass is M into G. This is the formula for weight. All of you remember that. Weight is equals to what? M into G. Okay? Yes. So now it is depend on direction. So that weight is a vector quantity or scalar quantity, all of you? It is the vector quantity. Because acceleration due to gravity is a vector quantity, it is depends on direction. So that weight is also what, guys? Vector quantity or scalar quantity? It is the vector quantity. Yeah, some people having disturbance, I think. Please check it that. What is the disturbance? Now, it is a vector quantity. Now, can you tell me it is due to the gravity? Then what is the SI unit? Anybody can tell? What is the SI unit of due to the gravity it is? So what is the SI unit, please? Weight is, yes, SI unit of weight equals to force. What is that?
kg
Yeah,
weight.
kilogram weight. Understanding? Newton.
Kilogram.
Newton. Newton first. Clear? Newton or kilogram weight. Okay, guys. How to write kilogram weight? If you write like this, it is wrong. Clear, everybody? How to write it? kg and subscript you have to write weight. WT. Is it okay, guys?
Yes, sir.
Yes?
Yes, sir.
Yes. Now, we will study. For example, if you take our earth is actually, it's not completely spherical in shape. It is a flat surfaces at the poles. Flat surfaces at the poles. Keep it in mind. We are having maximum gravity. Of course, what is the average gravity of earth? Anybody can tell? What is the average gravity of earth? 9.8
9.8
second square.
meter per second square.
Meter per second square. Keep it in mind, this is poles. At poles, the gravity is maximum. Okay, everybody? G is maximum at poles and G is minimum at equator. Minimum at equator. Sir, minimum means evala, sir? 0, sir? No. It is like 9.6, 9.72, like that. But approximately, exactly, averagely, what is the gravitational force of Earth, everybody? 9.8 meter per 9.8 meter per second square. So, even in the Earth, if you stand in the, suppose Tamil Nadu, if you stand in the Andhra, if you go to the Delhi, if you go to the America, everywhere the G value is not constant. Not only Earth, if you take moon value, G value is different. If you go to the sun value is different. Mars value is different. So G value is depends on mass of the object and some other factors. So now you tell me, if the G value is not remains constant, even on the Earth it is not constant. Do you understand what I'm saying, guys? Everybody? Earth also it will varies from place to place. So now you tell me, is it weight varies from place to place or not? Anybody?
Yes, sir.
Yes,
Yes, sir.
all of you. So that is what. So I can say weight is not remains constant. Weight varies from place to place. Okay, everybody. Now I already taught you where the G value is maximum, at the poles or at the equator. Everybody.
Poles.
Poles. Now can you tell me where the weight is maximum, at the poles or at the equator? Anybody?
Pole.
Poles.
At the poles.
Poles.
As G value is greater, the weight is also maximum. So where the weight is maximum? On the Earth. If you go to the other places, other planets, it is not remains constant. On the Earth, as we are living in the Earth, we can say weight on Earth, where it is maximum. Everybody, very important. Yes, please. All of you.
Poles.
Poles. Okay. Weight of a body is maximum. Okay. Maximum at the poles. Clear, everybody? Understand, Sanjay, Shivani? And minimum. Minimum at the where? Minimum at?
Equator.
Minimum
Equator.
at the equator. We can calculate that value also. We will study in gravitation chapter. We'll study that value. We'll calculate it also. Okay, guys? All of you. So why, sir, it is maximum here? Please note it that weight of the body is maximum because at that place G value is what? G maximum, minimum. Yes, please. Maximum. G maximum at poles. And G minimum at where, guys?
Equator.
G minimum at equator. Please write it. Everybody clear? Girls, boys, Hasinis, Alfin. That is what. Anybody clear?
Yes, sir.
Yes?
So one doubt, sir.
Hmm.
Sir, then if weight means force that we are applying means, then
Yes.
why, sir, all the times in our cities or towns, they are saying weight.
It is not
What
dependent
about
on.
mass?
Yes, Mari. That is a common language we are using. Understand, Mari?
Yes, sir.
Yeah. See, even you educated people also, you go and ask, suppose for example, you ask your grandmother, what is your mass? She will say, she won't say properly. She won't respond quickly. But you ask her weight, she will immediately will say. Understand? That is a common language we are using. That is why till 8th class, we will study that mass and weight both are okay, same. Understanding. But there is a difference. That is what. As we are a physics student, you should know that. That's what nothing is there. Okay, ba?
Yes, sir.
Yeah. Now, I am asking you the question. All of you, observe very carefully. You all studied the working against gravity and freely falling case. Do you all remember that? All of you? Freely falling case. Mr.
Yes, sir.
Nivedan, Lingesh, there are not meeting. Yes, please.
Yes, sir.
Okay. So that girl is asking, what is the SI unit? Okay, SI unit is kilogram weight. What is the CGS unit? She is asking. What is the CGS unit, guys? Dyne. Okay.
Dyne
Kilogram
or
weight also
gram.
we can call it as kgf, kilogram force. Dyne, and what is the unit R? We can say
Gram.
gram weight, or we can
Gram
say
weight.
GF, gram
Gram
force.
force.
Okay, wa? Clear? Now,
Yes, sir.
my question to you is, you think very carefully and tell me, as we studied free fall case, when the bodies keep on coming down, the velocity keep on increases or decreases, everybody? Velocity
Increases.
keep on increases. Decreases are. Yo. So
Increases, sir.
yeah, increases. Initial velocity is 0. Let me take here velocity is V1, velocity is V2, velocity is V3. Before touching the ground, velocity is what? All of you.
Maximum.
Before
Maximum.
touching
Maximum.
ground, V is maximum. We studied. Am I right, everybody? Clear? Yes? Now, I will say you device first. Remember, the weight is measured by spring balance. What is that? Weight is measured by
Spring balance.
spring balance. Now, I will take, for example, there is a spring balance. You all people can notice it. So spring balance will be like one spring will be there and one hook where we can attach the mass. And another side we will hold it. So that elongation of spring, the spring will be flexible. The elongation of spring will decide the weight of the object. There will be weight scale here. Newtons over side and another side it will be like a CGS or SI, or basically this side will say.
It will be only present in labs, sir.
Yeah, it will not only in labs, Mari. You can measure in your home also. You can. Now my question to you, Mari. I have given you, for example, 3 kg mass. How much mass?
3 kg.
mass. Understand my question and be smart and tell me. I have given you how much kg mass? 3 kg mass.
3 kg.
And now you are at a sea level. You are at a what level? Sea level.
Sea level.
Okay. Sea level, you are holding this one. Now you went to a small mountain and you are standing and holding the same spring balance and same mass. Now you tell me where the weight of the body is maximum. I want to know. Anybody? You are at sea level and you are at above the mountain. Yes, please. Yes, Mr. Sanjay Lingesh. You are at a mountain and you are at a sea level. Now you are measuring the weight. Measuring weight at the sea level and you are measuring weight above the mountain. Yes, Mari?
Weight or mass?
Weight. Mass is remains same. Mass is 3 kg only.
Yes, sir.
Yeah. Yes.
Sir, at sea level.
Yes. Somebody is saying something. Yes, please.
Sea level.
How?
Sea level.
What is your expectation? How it is? Anybody? Now, I will explain you. Observe very carefully. This is what is very important. Keep it in mind. If you consider this is the earth, all of you remember that. Of course, we all studied just now. At the poles, it is having maximum. At the equator, it is having minimum. Am I right, everybody?
Yes, sir.
But generally, you remember, earth is a spherical in shape. It is having a maximum force of attraction at the surface. Where it is that? At the surface. Clear, everybody? If I am going that above the mountain, means I am going above from the surface. At the surface, G value is maximum. Understanding? If I am going above from the surface, like height is keep on increases, then G value decreases. Is it clear? So that now you tell me where it is, weight is more, at the sea level or at mountain? Anybody?
Sea level.
Sir, mountain, sir.
Sea level.
Hey, mountain Gogol Raj. Enna Gogol? Mountain means it is height, man, above from the ground, above from the sea level.
Height increases, gravity decreases.
G value decreases means weight also what? Decreases. Urima,
Yes, sir.
understand? All of you?
Yes, sir.
Yeah. So you have to remember that. So height increases, gravitational force decreases or increases? Decreases. Okay. Since gravitational force decreases with the height, so what will happen, guys? The weight of a body is less on where? Respond, Ra.
Less on
The weight
mountain.
of a body is less. Weight of a body is less on the where? Mr. Sam? Less on the top of a mountain compared to where? Everybody. Compared to that at the sea level. Is it clear, everybody? Yes, please. So, and what is the device used to measure the weight, all of you?
Spring balance.
Spring balance.
This is measuring weight at sea level at mountain. So there is a person who is holding the spring balance. So you can remember that. And here also, there is a person. You just imagine that. There is a spring balance. Same 3 kg mass. Here also 3 kg. Okay, wow? Everybody clear? All of you?
Yes, sir.
Yes. Now, my important question to you. What is the dimensional formula of weight? Anybody can tell fastly. Dimensional formula of weight. Array, weight equals to force, ra. Then what is the dimensional formula? Also same. Dimensional
Yes,
formula of weight. Weight is equals to force. Weight is equals
M
to
power
force
1,
means
T
what is the
power,
dimensional formula? Everybody.
M
power
power 1,
L
T
power
power
1, T
L
power
power 1,
1,
T
T
power
power
minus
minus 2.
T power minus 2. Very good. Do it. Weight is equals to mass. Then dimensional formula is same. How to write dimensional formula? Theriyuma? We all knows that. Newton. Newton means what? Kilogram meter per second square. Kilogram means mass. M power 1. Meter means distance. L power 1. Time means time. T. Seconds means time. By it is. By means 1 by. So T power minus 2. That is what it is. Am I right? Everybody clear? All of you?
Yes.
Yeah. So what is dimensional formula? Weight is equals to dimensional formula of what? Dimensional formula
Force.
of force. Okay. So please learn it. It's very, very important. Okay. Next. So let us write a question. A coconut of mass 1 kg fall from a tree. Find its weight. As take the G value 9.8 meter per second square. So answer please. So very simple.
Sir, 9.8 Newton.
Yes.
9.8.
Mass is equals to 1 kg.
1 into 9.
Yes. Weight is equals to 1 kg into 9.8 meter per second square, which is equals to
It is equal to 9.8 Newton.
9.8 newtons. Is it okay, everybody? All of you? But 9.8 newtons equals to something. We already studied. Anybody can tell?
Sir,
9.8.
sir, 1 kg weight, sir.
Yeah, kilogram.
Gravity.
Gravity illegal.
1 kg
Kilogram weight. Another?
So 9.8 Newton is gravity's value, no, sir?
Yes, Mar. Yes, sir. Yes, Ra. 9.8 Newton is not the gravity value. 9.8 meter per second square is the gravity value. Now 9.8 Newton is a what actually? Gravitational unit of force. The force due to the gravity. So that I can say 9.8 newtons, which is equals to 1 kilogram weight. Am I right, everybody? Yes or no?
Sir.
Yes, sir.
If the same question will
Yes,
come
sir.
for MCQ, they won't give you in the newtons. They will give you in the kilogram weight. So by that time, you should convert the newtons into kilogram weight. Ellame puriyuma? Understand or not?
Yes, sir.
Yes. So what is the
Yes,
answer? You can say 1 kilogram
1 kilogram weight.
or we can say 1 kilogram what? Force also, kgf. Okay, guys. Understand?
Yes.
Yeah. So this is what
Yes, sir.
about what is mass and what is weight. I hope you all understand. Anybody having any doubt, you can ask me. Clear?
Yes, sir.
Yeah. So this is what about mass and weight. So with the help of this, then we are going to study the next concept is called as Newton's third law of motion. So please all of you keep it. Newton's third law of motion. Okay. Now for your school syllabus, you will get the mass and weight in third chapter. Gravitation chapter you will study. Okay. So that is anyhow, we are not following that here. We are only focusing on foundations. So it's not necessary to worry about it. But you understand or not? Everybody clear? All of you? That is what. Okay.
Yes, sir.
Now let us study Newton's third law of motion. What is this Newton's third law? This is very popular law. All of you remember. So nothing is there. For
Every
every action,
has an equal
yeah,
reaction.
every action, there is an equal and opposite reaction. Equal and opposite reaction. But I will use a word called as here. All of you remember, always Newton's third law is applicable. Two bodies are existed. Understanding? How many bodies totally? Two bodies. Okay. Because action must be shown by one body and reaction must be shown by what?
Another
Reaction
body.
must be shown by another body. Are you clear, everybody? Okay. So action and reaction cannot be takes place in the same body. Action and we are not like a Aparachitra Vikram movie, some movie erka and the madri. He himself, he will hit himself, he will turn. Action and reaction cannot be existed in the same body. Is it okay, everybody? All of you? Yes. So always action must be shown by one body and reaction must be shown by what? All of you? Another body. So that is what. So always how many bodies are involving? Newton's third law means all of you. Two
Two
bodies.
body.
Two
The
bodies.
first one is action and the second body, which we used to call it as what? We used to say reaction. Okay. So complete it till here. Make it fast. Action and reaction. So simply if you want to say action is equals to minus reaction, that is only called as what we used to call Newton's third law. Okay, guys? Yes?
Yes, sir.
Yeah. So then next we'll study what is this applications of Newton's third law.